What's up, class? Evans here. I've got something to go over with you, and that's civil engineering. So get something to write with, get a paper to write on, take a little bit of notes, and let's learn what civil engineering is. Well, just a quick summary of civil engineering. And you should be able to find this PowerPoint connected on Edmodo. Now, I can't show this video to you on my video because then it gets some weird feedback going on. So pause my video or now and watch this. What do civil engineers do? Or after my video, come and check out this one. I would say watch it first. All right, so here's our definition of civil engineering. And yes, that is the bridge at South Padre Island. So civil engineers, they design, they construct, and supervise. Hey, covering up my face. They operate and maintain large and small construction projects and systems, including roads, buildings, airports, tunnels, dams, bridges, and systems for water supply and sewage treatment. Basically, everything that society uses together as a whole and very much take for granted, that's what civil engineering covers. The water that comes into your house, the sewage that leaves your house, the roads that you drive on, power lines, all that stuff that we use as a whole, civil engineering is needed in order to produce those site maps and get those systems made and built. Now, to be a civil engineer, you need a minimum of a bachelor's degree and a license. And civil engineering is the only engineering system that has a licensing like this. It actually, I think, even started in Texas. It's got an interesting history if you get a chance to look that up. Now, what do civil engineers typically do? Well, they analyze survey maps, estimate construction costs. You don't want to build something if you don't have an idea of how much it costs. Factor in potential environmental hazards in order to protect our land and ecosystems. They work with permits. Both local, state, and federal agencies produce permits that civil engineers need to know how to work with. They will test building materials, use design software, even like what we use, AutoCAD, though many times it's more of a 2D nature, or Autodesk. Oversee construction projects and maintain existing public infrastructure. So let me show you a couple of engineering careers that you could find under civil engineers. One would be like construction engineering. Construction engineer, they maintain construction projects, ensure that they are on schedule and built to plans and specs. They work with highways and bridges and airports. Some of those really big projects are where you'll more than often find a construction engineer. They're like a construction manager. They have a little bit less design work as they are more so on the field to make sure it gets built to the designs. So they actually have to know a lot about the design itself because they're going to be making sure it's done right. If you like math and science, and to be honest, if you like working outside, this might be the job for you. I've had people in the past tell me they don't think, friends, that they don't think that they could get a 4-year degree because they couldn't see themselves like working in an office for the rest of their life. Like they need to be able to go outside. And civil engineering is one of those unique, I would say, unique types of engineers where they are often going outside. And if you work for a large company, you might always be outside, like a construction engineer. A smaller company, you might be doing a little bit of everything. You might be designing some of it and then going out and checking the site. And so that would be a construction engineer in a smaller town and smaller projects might be doing a lot of things. In a big company, you might get hired to just do to design or just do the construction engineer position. This right here, these things are here so that when they dig holes that are deeper than I think 5 or 6 feet, law requires that they put these shore systems up. This is so that if the dirt collapses, it doesn't collapse in and kill the people. So that's what these walls are here for. It keeps them safe as they work in a pretty deep hole. That's a large building being built. Geotechnical engineers. This one's pretty interesting. Their focus is on the earth, and they know a lot about erosion and soil types and rock types. Interesting, at least to me. They focus on how structures are built by civil engineers and how they interact with the earth. Designing slopes, retaining walls, tunnels. So you'd want a geotechnical engineer if you're doing tunneling for sure. If you're going to build anything that sits on top of the earth, you're going to need a geotechnical engineer to go out on site and collect some drill samples because you want to know the exact type of dirt that you have on that location. Because you can't just put a building on the ground. You need to work with the type of dirt that's there. Often you need to bring in select fill and caliche in order to make it a very stable and firm earth. You gotta compact it down, and then you can put like your asphalt or your concrete on top of it. You also need geotechnical engineers to come in and test different types of concretes to make sure that the concrete is the correct grade, because the concrete that you're going to use for your sidewalk on the side of the street is completely different for the type of concrete that you're going to use for like to line the a ditch with concrete so the grass doesn't grow up and the water flows really nice, and would be totally different than the type of concrete that you might use to put underneath a bridge or a causeway going through the water or a skyscraper. There are totally very different types of totally very different. Anyways, there's different types of concretes, and they have very different types of strengths and different types of um, rebarb structure inside. They give them various different ability to last longer and the ability to handle hard, better strengths, better forces. See, concrete's a unique structure. Concrete itself uh, takes about 48 hours to cure, which means come to about its maximum strength. It actually continues to cure as it goes. The water inside of it evaporates over time, uh, and that's kind of a curing process. And it's not still. If you ever notice, concrete has those lines cut into them, and they often have like little wood or like caulking put in between those cut pieces. That's because the concrete actually shrinks and contracts with the seasons. If I remember right, it shrinks in the wintertime when it gets cold, and uh, it expands again in the summertime when it gets hot, and that actually causes it to crack. The concrete itself wants to pull apart. The metal rebarb on the inside wants to hold it together. So you need both. If you just pour the cement without the rebarb or some sort of metal mesh holding it on the inside, it would crumble into rocks in a few years. Structure engineers. Now, a structure engineer might actually have a bit of a higher education, at least a master's, because they're going to be working with larger buildings. This is not smaller structures, of course, but larger structures, things of multiple stories, big dams, big bridges. They design and estimate the value of major projects such as buildings, bridges, as I just said, dams, to ensure their strength and their durability. Environmental engineering, this one's a little bit new. They develop solutions to environmental problems using things such as soil science, biology, and chemistry. They might have further education. Not sure where the lines between environmental engineering and environmental science blur and diverge. They would be very similar fields. Working to improve systems like recycling, uh, waste disposal, public health, and water and air pollution control, working on problems like that. Transportation engineers, um, as the name sounds, it works with systems that work with transportation of vehicles. This could be regular roads, and in a larger area, you might be talking about like those huge clover leafs where you have two large roads, like two highways intersecting, and you don't want to put a stoplight to stop them. You want the traffic to be able to keep high speeds and just keep moving. Um, to public transit like subway systems, and a network of lights. Now, they do have licensing, like I said before. In order to get licensed, I had started the process myself, just as I had gotten outside of college. Um, they'll work on projects as engineers that the public will use. So anything that the public touches, you need to have licensing for it as a civil engineer. Each state has their own licenses. Texas is the second hardest test. The first one goes to California because in California, you need to know how to handle earthquakes. So it's a whole other section that civil engineers mess with around California that they don't mess with really in Texas. You think maybe tornadoes would have an effect, but I guess when the ground underneath your building is moving is probably a lot harder to deal with than high winds and a tornado. Um, To get your license, there is a test you have to take while you're in college typically. It's an 8-hour test. It's really hard. It's called FE, your fundamentals exam. After you pass that, you get your EIT, which is engineering training. And I had done that myself once I had just about finished college. You need to work under a PE or a professional engineer for 5 years. If you do have a master's in civil engineering, then you could do it for 4 years. And I had started that process myself. When you present your work, then once you pass that 5-year span, like I had said, then you are able to present your work of various projects for review to a board, actually a state board. And then you would take your final exam. And once you pass that final exam and you go through the review process, um, then your signature is money. You can start your own civil engineering firm and you can sign your own plans and you get a registered seal and your name is money. Of course, you've got to be able to back every project you do, so you just can't sign off on things. So you actually know what you're doing. Um, Now, I wanted to show you just a little bit of civil engineering just within your own campus. So here's Dr. Kano Academy pretty soon after it was built. Before it was built, there was only a field there, just grass. So the question that I want to show you is think about the rain. Rain soaks into the ground. In fact, I think I can't remember, something like 85% of the water that falls on the ground tends to soak into the ground. Of course, depending on the dryness of the land and how wet it already was and super saturated it was ahead of time. But in a typical rainstorm, that's about how much soaks in the ground. It might be less than that. Anyways, a lot of water soaks in the ground on a normal day when it rains. Now, once you take that ground and you build a parking lot on top of it or building, you are now taking away square footage that can no longer soak up water. So what happens to all that water that gets displaced? It doesn't get soaked into the ground. It ends up going into the buildings that you just built or into the neighborhood next to you. And then you destroy your building when a hurricane comes in, or you flood out your neighbors and then they sue you. So in order to handle that, you need to be able to calculate how much water might fall on a severe storm. Not talking about an act of God storm, not talking about a storm that floods out the whole city. We're talking about a storm that isn't flooding out anybody, but would create enough water that would normally soak in, that if it couldn't soak in, it would cause a flood. Now there's a way to calculate that, and I want to show you here on the school. I really hope that we get the chance to walk around campus uh, and see these things firsthand. I guess I'll just show you by pictures. Maybe this is something we'll get to do when we meet back on campus before the end of the year. So this is the school campus. Was a field before then. This neighborhood, sorry, this neighborhood's been here a while. This one too. In between them is it's actually not a drainage ditch, it's an irrigation ditch for farmers and ranchers and so forth. This all used to be ranch land, farmland. Out here in the front, you have a drainage ditch. What's missing is the little road that's here that got built in 2019, actually, just the beginning of last year. And then you've got a drainage ditch right here around the student drop-off and pickup area next to the bus area. And then past the practice field here, you'll actually have a whole nother drainage ditch back there. It's actually a pretty big ditch. But let me zoom in. So here's the ditch in the front. It's supposed to be dry. There's only supposed to be water in there when there's a pretty big storm. This is the size of the ditch, and that's the bottom of it. You can see, oh, my head's in the way, but there is a drainage grate right there and right there that you can see, and there are underground piping that's connected to them. And then there's a pipe that goes under the ground here and connects back to all these other ditches, or I mean all these other little drainage pipes that are there. Underground connects by pipes. The closer it gets to the ditch, the deeper it goes underground before it comes to this exit point. At the front of the school, if you look at it from the side, you can see it's not very steep. It slowly goes down. You could think of Algebra 1, that's slope, rise over run. In fact, that's actually how the engineers typically describe it. They give it a rise over run rating. They don't give it an angle. They tell them it's so many feet by so many feet in terms of goes out 4 feet, goes down half a foot. That's how they describe it to the construction workers in order for them to make it. They give it in slope form. Out here in the front, you'll see this drain outlet or inlet. The water along the street flows down the street like a river. There's a high point on the street and there's low points, and at the low points, they put these. It's actually passes underground here. And if you look in the parking lot, there's one drainage ditch here. So there's, a drainage inlet. So there's actually a pipe that goes under the road, connects to here, and then goes into the ditch. So all of the parking lot drains into that one area, which connects to the one that's on the street. This part of the street here, and there's actually a whole nother parking lot area here. This part drains down this little slide here and goes into the rubble riprap, little larger pebbles that are there. This one ditch on the other side, so this is getting this side of the parking lot, and this is getting from the road that goes this way, and all the water coming off the building on the west side of the building. This one right here is different from these other four. This is actually the exit point. So all the water goes in through these four inlets and falls down from the sky, fills up this area, and then this goes into underneath the street of Lozano and goes out to the west to the drainage ditch out here over by these metal buildings. That's where it all drains out to. I've actually come up to the campus when it's rained pretty badly, and I took some pictures of it. So this is the practice field in the very back, completely flooded. You can see here's the school. There's the actual football practice field. And then here's the drainage ditch on the side, and you can just see how full that thing is. This is what it looks like in the front of the school when it rains. Now, I took these pictures, I think 2 days after it rained a few summers ago. It actually rained real bad, and it flooded so bad I couldn't even get on the streets to get there because they were so flooded. So the water actually came way down from where it was before. I couldn't even drive there. The streets were too flooded. So you can see how much water it does hold as it fills up. So let me tell you what your assignment is for this civil engineering notes. I hope you wrote stuff down and keep those for when we get together. We can tape them in our notebooks and at least have a finished notebook for the end of the year. Your job is to look around your neighborhood and take pictures of the drainage structures that you see. Look at the road. Notice how the road is actually crowned. Crowned means it's crowned means it's actually like rounded. It's not. It's the roads aren't typically flat. They're actually rounded. And look at the drainage inlets and see if you can find a picture of a ditch or some other drainage structures that are right in front of your house that you probably never thought about. The curb on the side of the road. I want you to take a few of those pictures, do a cheesy selfie so that I know it's your picture and no one else's, or do a quick video with your phone showing me some of the drainage structures that are right around your neighborhood. And then I want you to email them to me at justin.evans@hsd.org. And in the subject title, I want you to put your class period, like first period, and then your name. Put that in the subject title, attach your picture or your video, and that's your first assignment. I wish you luck. Have fun with it. Enjoy it. If you don't know the names of things, look them up on your phone and find the name of them. And I'll see you later. You can always email me if you have questions, or you can leave comments in the Edmodo comment section, and I'd love to answer them. I hope to see you soon.